Section 3.5 is solving inequalities by multiplication or division. I can solve inequalities using multiplication or division. That's our learning target and what we're shooting for in this section. Multiplying both sides of an inequality by a positive number produces an equivalent inequality. The same is true for division because the rules for division are just like the rules for solving with multiplication. So, dividing each side of an inequality by a positive number produces an equivalent inequality. In example 1, if we look here, m is being divided by 3. We can get rid of that division by multiplying by 3 on both sides. Whatever I do to one side, I have to do to both. Here I get 3 divided by 3, which is just 1m, and 3 times 3 is 9. I don't have to change my inequality here, guys, because I multiplied by a positive number. So 1 times m is just m. So I get m is greater than 9. We can check that from our graph. So the first thing I'm going to do is graph. I'm going to put my boundary point in the middle, and I put one number bigger, one number smaller, and about where 0 is. Doesn't have to be to scale, but on which side. I put a circle at that boundary point, and because it's not equal to here, I don't fill it in. Now, we want numbers greater than 9, like 10. So since 10 is a solution, that's the side we're going to shade. To check our solution here, I check two things. I check first that my boundary point is right. So I take 9 divided by 3 should equal 3. 9 divided by 3 is 3 equals 3. My boundary point is right. Now, I want to check a number to see if my shading is right, if my inequality is right. I'm going to pick 12 because 12 is divisible by 3. So 12 divided by 3 should be greater than 3. Here, I get 4 is greater than 3. That checks. So our graph is correct, and so is our solution. In example 2 here, t is being multiplied by 10. We get rid of multiplication by dividing by 10. And whatever I do to one side, I have to do to both. 10 divided by 10 is just 1. 34 divided by 10 is 3.4. And I still have that 1 times my t, and my inequality hasn't changed either. 1 times t is itself, so I get t is greater than or equal to 3.4. And again, because we divided by a positive number, our inequality stays. So to graph here, on my number line, I'm going to put my boundary point, that 3.4. I want to put one number bigger, which here is the whole number 4, a number smaller, the whole number 3. And I want to put 0. We put a circle at that boundary point, and because of my equal to line here, I fill in my circle. We want numbers that are greater than 3.4, like 4. So we're going to shade everything on the same side as 4. Now, let's check. Two things we're going to check here. I'm going to check my boundary point first. I'm going to say 10 times what I got as a boundary point here, 3.4, should equal 34. And that'll tell me if I have the right boundary point. Here I get 34 equals 34. It checks. The second thing I want to check is 10 times some number in my solution to see if it is greater than or equal to 34. We can pick any number. We can pick 4 here. Because that's part of my solution set, that'll work. 40 is greater than or equal to 34, which is true. That checks as well. So my graph is correct, and so is my inequality. Here, for the first time, is where things get different. For the first time, it's not the same as solving equations. If we multiply both sides of an inequality by a negative number and reverse the direction of the inequality symbol, that's how we get an equivalent inequality. The same is true for division, because the rules of using division are just like the rules for solving an inequality using multiplication. So, dividing each side of an inequality by a negative number and reversing the direction of the inequality symbol produces an equivalent inequality. So if we multiply or divide both sides of an inequality by a negative number, we have to flip our inequality. So instead of being less than, now it's greater than. Instead of being greater than, now it's less than. The equal to part doesn't change, so it's either there or it's not. But our inequality itself does, because remember, when we multiply by a negative, it's like taking the opposite, so our relationship becomes the opposite as well. In example 3 here, m is being divided by a negative 3. Take the sign with the number there. So to get rid of division, we're going to multiply. I'm going to multiply by that negative 3. And whatever I do to one side, I have to do to both. So negative 3 divided by negative 3 is just 1. 3 times negative 3 is negative 9. I keep my m, but because I multiplied by a negative number, I have to flip my inequality. So my answer here is actually going to be m is less than negative 9. When I go to graph it, I put that boundary point in the middle, and then I put the next number bigger, the next number smaller, and 0. At our boundary point, I put a circle. Here I don't fill it in because it's not equal to. And then we look. We want numbers that are less than negative 9, like negative 10. So we shade everything on that side. Now let's check it. First thing I'm going to do is check my boundary point. So negative 9 is that boundary point. I'm going to divide by that negative 3, and it should equal 3. Here, negative 9 divided by negative 3 is 3. It equals 3 and checks. The second thing we want to check is to see if our shading is right, if our inequality is right. So here, I'm going to pick a negative 12 because 12 is divisible by 3. So negative 12 divided by negative 3 should be greater than 3. Again, we go back to our original problem to check with. Here, when I reduce, I get 4 is greater than 3, which is true, and checks. So my inequality is right, my relationship there, and so is my graph. For example 4, t is being multiplied by negative 10. So I'm going to go ahead and divide both sides to get rid of that multiplication. To get rid of multiplication, we divide, and whatever we do to one side, we have to do to both. Negative 10 divided by 10 is just 1. 34 divided by negative 10 is negative 3.4. Now, I didn't change my variable, but I have to check my inequality here. We divided by a negative number, which means that inequality has got to flip. So here I have t is less than or equal to negative 3.4 because 1 times t is itself. As far as our graph goes, I'm going to put that boundary point on my graph, negative 3.4. I want the next number bigger, negative 3, and the next integer smaller, negative 4. I also want 0 on my graph. We put a circle at our boundary point here, the negative 3.4, and if I look, it's equal to, which means I fill in my circle. We want numbers that are less than negative 3.4, like negative 4. So we shade everything on this side to the left of 3.4. To check, we're going to check both our boundary point and our graphing. So negative 10 times, my boundary point is negative 3.4. And I want that to be equal to 34. When I check here, I get 34 equals 34. That checks and we're good. The second thing I want to check is my inequality symbol. So I'm going to fill in negative 10 times one of the numbers in my solution. So something like negative 4, something in my shading to see if I'm correct. And I want that to be greater than or equal to 34. Again, we check that original equation. Here, I get 40 is greater than or equal to 34, which checks. So our graph is good, our inequality symbol is good, and overall we are correct. Feel free to pause here and give these a try if you'd like. In number 1, n is being divided by 6. To get rid of division, I'm going to multiply. Multiply both sides by 6. If we change one side, we have to change both. 6 divided by 6 is 1. 7 times 6 is 42. We didn't change our n, and here since we multiplied by a positive number, our inequality stays as well. 1 times n is just n, so we get n is greater than 42. To graph it, we put that boundary point I put the next number bigger and the next number smaller, and I want to have 0 on there as well. Put a circle at my boundary point. Here it's not filled in because it's not equal to. We want values that are greater than 42, like 43. So we shade everything on the side with 43. Now let's check it. Here I checked both my boundary point. 42 divided by 6 is 7, that checks. And I picked a number that was in my solution set. I picked a multiple of 6, 48, so that when I divided, I got a whole number. 8 divided by 7 checks. We are good. Feel free to try number 2. Right now, t is being divided by -4, so we get rid of it by multiplying by -4. And whatever I do to one side, I have to do to both. -4 divided by -4 gives me 1. -8 times -4 gives me 32. Now, I didn't change my t, but my inequality has to flip. Because I multiplied on both sides by that -4, my inequality has to flip. We did the opposite. We used to have a -8, now we have a positive. It's opposite, which means my inequality flips as well. So here, 1 times t is greater than or equal to a positive 32. To graph it, I plot that boundary point and one number greater, one number smaller, and where 0 is. Put a circle at my boundary point. Because it's equal to, I'm going to go ahead and fill it in. We want numbers that are greater than 32, like 33. So we shade everything on the same side as 33. And now we can check it. Here I plugged in my boundary point equal to -8 and got a true statement. And I picked a number bigger. I picked 36, which is a multiple of 4, so that I'd get a whole number. -9 is less than -8, so we are correct. In 3, x is being multiplied by 2. We get rid of that by dividing, and whatever I do to one side, I have to do to both. 2 divided by 2 is 1. -8 divided by 2 is -4. I didn't change my x, and I don't have to change my inequality here because I divided by a positive number. 1 times x is just x, so I get x is greater than -4. To graph, I plot my boundary point and the next consecutive number bigger and smaller and about where 0 is. I put a circle at my boundary point. Here I keep it open because it's not equal to. We want numbers greater than -4, like -3. So we graph everything on the same side as that solution. And as you can see there, they both checked. Here, s is being multiplied by -7, so I divide both sides by -7. -7 divided by 7, -7 is 1. 14 divided by -7 is -2. I keep my s, but because I divided by a negative, I have to flip that inequality. It becomes a less than or equal to. So here I get s is less than or equal to -2. I set up my graph, put a circle at -2. Here I fill it in because it's equal to. And I want numbers less than -2, like -3, so we shade everything on that side. Here I checked. We're good, and that's all for section 3.5.